Welcome to AP Chemistry Periodic Table. Today we're going to be talking about atomic radius. Specifically, we're going to be looking at the definition of atomic radius, trends down a group, trends across a period, comparing radii of atoms and ions, and finally some periodic trends with ions. Atomic radius is an estimate of the size of an atom, where if we look at this model right here, atomic radius is from the center of the atom to the outermost valence electrons. That is the atomic radius of a single atom. Atomic radius trends down a group. Atomic size will increase from top to bottom. The outer electrons have higher principal quantum numbers, or n, thus a greater possibility of being farther from the nucleus. So if we look at this diagram right here, we can see in group 1, if we look at the lithium atom versus the sodium atom versus the potassium and the rubidium, we can see the radii getting larger as we go down the group. And that happens for also group 2, group 13, group 16, and group 17. That the general trend is the atomic radius will increase as you go down a group. So this applies to both metals and nonmetals. Atomic radius trends across a period. Atomic size will decrease from left to right. When we look at this, we observe that the number of core electrons will remain constant while the nuclear charge increases. Now, what does that mean? That means the number of protons in the nucleus will increase as you go across a period, but the number of core electrons will stay constant. At the same time, the number of valence electrons in the outermost shell will also increase by 1 across the period. So in this situation, the number of protons will increase as you go across the period, and the number of valence electrons will also increase as you go across the period. And as a result, the atomic size will decrease because as the number of protons increases and the number of valence electrons increase, that Coulombic attraction occurs, and we see this general trend of decreasing atomic radius as we go across the period. So again, we could look at, starting with lithium, the atomic radius going across in period 2 and see it goes from 134 to 90 to 82. With the metals, we see the same trend with the nonmetals as oxygen goes from 73 to 71 as we go across the period with the nonmetals. So the general trend again is the atomic radius will decrease as you go from left to right. Comparison of atoms and ions of the same element in angstroms. Cations, or positive ions, are always smaller than their parent atoms. Electrons are lost from the s and p orbitals to form a more stable noble gas core. So a sodium atom with a radius of 1.54 angstroms, when it loses its outermost electron to form a sodium ion with a charge of +1, the radius will decrease. And again, we can see that in the model down here. The sodium atom radius is 1.54, and the sodium ion radius as a positive ion, of course, is 0.97. Anions, or negative ions, are always larger than their parent atoms. Additional electrons cause increased electron-electron repulsions, causing electrons to spread out. So as we add electrons to that outermost shells, the electrons are going to repel each other, therefore increasing the radius of the ion as they gain electrons. So if we look at a bromine atom, it has an atomic radius of 1.14 angstroms. But when we add that extra electron to that outermost shell to make a bromine ion of a -1 charge, we see that the radius of the ion now is a little bit larger, of 1.96 angstroms. Comparison of ions to other ions. The trend is the same as in a neutral atom. The size of both cations are positive ions and anions are negative ions will increase down a group. So in group 1, we see that whether it is an ion or an atom, the radius is going to increase. Same thing for group 7A or group 17. whether it's an atom or an ion, as you go down the group, the radius will increase. This trend holds constant as we look at radii across a period. The trend is the same as in a neutral atom. The size of our cations will decrease across a period, as we can see here. The lithium ion is 0.68, the beryllium ion is 0.13, the boron ion is 0.23. The size of the anions will also decrease across a period. Again, as we compare an oxygen ion of 1.40 to a fluorine ion of 1.33. So what did you learn? We looked at the definition of atomic radius. We looked at trends down a group, trends across a period. We compared radii of atoms and ions, and then we looked at periodic trends with ions. Need more help? Feel free to contact me. Have a great day.